Hey guys, hope everybody's doing well. It's first thing in the morning, getting into the shop. Yesterday, before I left, I was thinking about some things, and the main thing was talking about what the purpose of this YouTube channel is. I've always wanted to bring knowledge to all of my viewers and, of course, all of my customers. And I think that's kind of the direction this channel is headed, is to educate and to answer questions. So I've been thinking, obviously on YouTube there's a ton of information on turbos. I haven't sat down and watched much of it at all, I'll be honest with you. So with that being said, a couple of my friends have pointed out some things, and and it aligns with my thought process as well. So we're going to start kind of from the ground up. I'm not going to say we're starting at ground zero, but I'm going to try my best to educate you guys as much as possible on a turbocharger and its inner workings, its function. Provide as much insight as possible to help you guys understand what goes on and how these things work and what can be done to them, what can't be done to them. Basically, I want to cover it all. Let's see here. Let's zoom out a little bit. See if I can. I'm a one-man show today on the camera, so. I've taken a brand new Garrett G47, pulled it apart, and got to do some updates to this one. So I figured it'd be a great showcase turbo to kind of go over a few of the component parts and what they do. It's big enough to see everything closely, and it's also got a lot of newer technology that applies to even turbos much smaller. The Garrett G series, several of the journal bearing turbos of modern day carry a lot of the same features as this one, but we're going to focus on the G47, which will also be the GTX 47. It'll also be the G50, G55, G57, GTX 50, GTX 55 ball bearing or R series turbos. I'm going to try to keep this video, it's going to be technical, but I'm going to try to keep it on an entry level or like a 100 series course at this point. So for all you hardcore tech guys, don't worry. We're going to get more in depth on each component part as time progresses. But I wanted to get this one out here pretty quickly just to help with some understanding and just to educate you on an entry level. Pulled this thing apart, and probably the first most notable piece that everybody identifies is going to be the compressor cover. Its job is super simple. Its job is to collect the air for the compressor wheel, give the compressor wheel the features it needs to do its work, and also to connect that airflow from the atmosphere to the engine. The compressor cover has quite a few attributes that we will get into very specifically in some more videos, but all intents and purposes, it is a bore, a radius, a diffuser, a volute, and an outlet. The purpose of each one of those is very specific, from collecting the air on the inlet side for the compressor wheel, stacking the air, turning the stacked air into pressure, and supplying it to your engine. Well, try not to sound so dry. Have some humor. This compressor wheel, it really should be called a suction wheel, but we will get into that a little bit more in detail. But the compressor wheel's job is simply to move air from the inlet or inducer to the outlet or exducer and accelerate that air into the diffuser area of the compressor housing. Compressor wheel or suction wheel? To be answered in a future video. The next part we will discuss, we've got a few to choose from, obviously, so let's make some room. Let's continue with the rotation group or rotor group. This is the exhaust wheel or turbine wheel. Inducer, this is what touches the exhaust air first. Exducer, or the minor diameter, that is what expels the air out of the turbine housing. The shaft. The quill. The quill is what holds the compressor wheel. The shaft is what holds the bearing structure. I haven't removed the seal rings off the exhaust side, but these are your exhaust side gas seals. So what everybody calls the turbine seal or exhaust seal in a turbo. They are just piston rings that fit onto a machine groove on the shaft. Very similar to a piston ring in a transmission or an engine. Their purpose is to keep exhaust gas separated from the internal workings of the turbo. They also provide a very small amount of sealing for the oil from the bearing structure into the exhaust housing as well. As you can see, the seals are very robust. They are made out of a high temperature alloy, and they are very, very resilient. So if you ever hear somebody say, I blew the seals out of my turbo, that's kind of a running joke inside of any turbo shop. Pretty hard just to blow one of these guys out. But don't worry, we're going to cover that in a video. How seals fail, why they fail, how they can and can't do their job. That's coming. We'll bounce back to the compressor wheel just in case I didn't cover it. Inducer, which is your minor diameter. This is what most people refer to as the size of the wheel. This one's 80 millimeter. Exducer, or the major diameter. This one is 109 millimeter. Inducer, exducer. So if you hear that term, that's what that is covering. Everybody wants to see it. We're going to go over some 5-axis machining paths, some videos on how these are made, how they're balanced, tolerances that are kept. All that's coming. Back to the rotor group. This piece right here, this is your oil flinger / seal holder. Just like the exhaust side has seals, the compressor side must be sealed as well. This one has 3 smaller piston rings, and I'll show you where all these rings go here in a few. But this piece simply rotates with the shaft and holds the seal, and also has what we call an oil flinger, which we'll get into here shortly, to help keep oil away from that. The primary function of the compressor side seal is to keep boost pressure, vacuum, any type of outside air from getting inside to the bearing structure. It also does keep a small amount of oil out of the compressor housing. Since the compressor side seals do not see nearly the heat that the exhaust side or turbine side seals do, they're much smaller. They are a similar material. just not as high temperature, so they don't have to be as robust. The next piece of the puzzle is going to be the seal plate. This is the compressor side seal holder, or seal plate. So it has a bore. Your oil flinger, seal holder, it fits down in there. The clearances are roughly 1/1000 side clearance and between 4 to 8/1000 in gap on your piston ring. Remember me saying this was an oil flinger? As this piece rotates, it centrifuges oil into this collection area and away from the seals, and hopefully keeps it out of your compressor cover. Oil flingers are very important. The turbine wheel has one as well. That is this machine feature right here. This sharp change in geometry creates a nice parting line for oil. As this turbine wheel turns, it flings the oil, or hence the word flinger, off into a cavity in the bearing housing and keeps it away from the exhaust seal ring. We'll go a little bit more into depth real quick on why flingers are important, and sometimes why large turbos on small engines may not do as good of a job as they need to in the sealing department. We have a ton of engineering, obviously, in these parts. This size exhaust wheel is normally reserved, well, originally the GT47 size wheel was very popular in a Caterpillar 3406 engine, which guys, y'all stand me corrected, I'm sure, on this, but it's basically a 15-liter diesel. So when we go put this size turbo on, let's say, a 6-liter LS or a 5-liter Coyote or a 2J, 3-liter Supra or an RB26, you obviously do not have as much exhaust energy as that 15-liter Caterpillar does. So what that means is at idle, this rotor group does not spin as fast. So this flinger does not do as good of a job at lower shaft speeds. So what does that equate to? Over time, that can give you problems with oil turning into carbon, oil getting past the exhaust seal, oil creeping up into this area when it's not supposed to. So I said I was going to keep this pretty simple, so I'm not going to go much further into depth, but this is just a little taste of what we're going to discuss in some of our future videos, is how all of these features work. Let's get on to, we'll go ahead and talk about the bearing. This is a bearing cartridge. The Garrett bearings are a multi-piece that consist of in this one's case, ceramic bearings or balls. The material can vary depending on model, but in this particular turbo, they are ceramic. This one has a metal cage, simply to hold all the balls and keep them equally spaced. An inner race, which is what the balls roll on the shaft side. So this piece, when it's all assembled, rides on the shaft. And then an outer bearing shell, which contains your outer race. There are two sides, your exhaust side and your compressor side. There are slight differences in the cage material between exhaust side for heat and the compressor side. Some of them are phenolic, some of them are this alloy. And it can vary depending on its application. We've seen some engines with alloy cages on both sides. We've seen some engines with phenolic cages on both sides. That's going to vary a little bit, but all in all, they all perform the exact same. When this whole piece is assembled, the inner race, the balls, the cage, everything, you get your whole bearing cartridge. The bearings are fed oil from the bearing housing into these passages here. It's not going to show up on my camera, but there are actually two holes. This first outer hole, and then there's a very small inside hole. That hole provides a bearing spray or an oil spray to the bearing instead of just flooding it with oil. It helps a roller bearing perform better. This groove around the bearing cage is mainly there to provide a cushion of oil, a supply of oil, and it also does a good job of separating contaminant. The contaminant will fall to the lower side in the bearing housing. This is your feed side, so this will be up at 12 o'clock. So this is like a contamination trap and also a oil collection area, so you make sure that your bearing always has adequate amounts of volume. Again, we'll cover more of that later. Bearing housing. This is the main center section of the turbo. It has the back plate, which connects the compressor cover. It has the turbine side V-band flange, which connects the exhaust housing. Also has your oil inlet and your oil outlet. The bearing, it is simply located right in the center. And these are aluminum, and sometimes they take just a tad bit of heat to get them to slide together. But this one's going to go pretty nice. So the bearing fits in there just like that. Remember me telling you about your oil flinger and showing you this little feature here. This is where all of that oil goes. That cavity is connected directly to your oil drain. So as your rotating group spins, it centrifuges the oil, the excess oil, into that area there and drains it back into the engine. The seal plate. This will fit into here. I don't have everything snapped together. At that point, you've got a heat shield. This simply protects the bearing housing from direct heat from the exhaust, and I'll show you that here in just a second. I'll get my morning workout today, holding up heavy turbo parts. Exhaust housing. Exhaust in from your engine. That exhaust travels around this volute, which is essentially a nozzle that accelerates your exhaust gas and ultimately directs it to the contact of the inducer of the turbine wheel, providing rotational energy for the compressor. The heat shield, when it's on the bearing housing, it goes into the pocket there. And like I said, it just helps complete this exhaust housing, and it gives a path that directs it entirely to the turbine wheel and keeps as much heat off the bearing housing as possible. Exhaust housings have different AR numbers, or area over radius, and I'll go into that in great detail, but the short version of it is, the smaller the number, whether it's an AR number or a centimeter squared number in some European and Japanese turbos, That number, the smaller it is, means the nozzle goes from one size to its smallest size in a tighter radius. I won't go into all of the details here. We'll cover a whole video there, but essentially the AR has to be chosen to give you enough response for your engine while not creating choke flow. That's a hard thing to cover in some applications, but we will get through it. The rest of the component parts are pretty simple. They are O-rings for sealing your compressor cover. I do want to take just a second and talk about it because this is definitely an entry-level point to make. If your turbo does have a compressor side O-ring, please make sure to lubricate it. I generally like to use silicone grease. Vaseline will work. Just know that if your O-ring is orange or red, it's most likely silicone at that point, and petroleum products will make silicone swell and become fragile. This O-ring is either it's for all intents and purposes rubber. It's BUNAN, or some of them in the higher temperature ones will be Viton, and they are okay with most petroleum products, so you can use like Vaseline or a light coat of motor oil. But the reason why you want that O-ring lubricated is pretty simple. When the compressor cover, we'll pretend that this is a turbo ready to go together. When the compressor cover is attached to the back plate, that O-ring needs to be able to take a seat and find its home. Also, if you're in the process of doing your fitment, a lot of times you will have to turn the compressor cover. The lubrication there just makes that happen effortlessly and also keeps the O-ring from getting pinched or torn, both of which can have catastrophic results if not caught. This is equally important that I will discuss right now. It is imperative that anytime you loosen and rotate or loosen and retighten or reinstall housings, to make sure that the rotor group spins. Not only turns, push it back and forth, make sure it gets no contact between the compressor cover and the compressor wheel or the turbine wheel and the turbine housing. Also take the time to do a visual. Let's see, I don't know if I'm going to be in frame or not right there. I was going to try to not flip y'all around. The visual side of things is very important. Look at it, make sure your eyes are pretty accurate. Make sure that the wheel looks centered in the compressor cover or the turbine housing. Make sure that there's no damage to the wheel from where you slid the housing on or any other foreign objects that might have gotten in there. So with that being said, the exhaust side is equally important. Make sure that your mating surfaces are clean. Make sure that you use a small amount of anti-seize between the bearing housing. Here, I'll go ahead and show you where. Get you back flipped around here. So your registration flange is this area here. This is where the bearing housing seats into the turbine housing. That needs to be as clean as possible. Because this registration groove in the bearing housing has to mate up with it perfectly. Remember me saying the compressor wheel to compressor housing clearance is tight. Well, the exhaust wheel to exhaust housing clearance is equally as tight. So Any misalignment between surfaces, whether it's from a pinched O-ring or from a mating surface that's not clean, will just about guarantee interference between the compressor wheel and the cover, or the turbine wheel and the cover. And that is not going to do anything for life expectancy of your turbocharger. So let's see. I covered the compressor wheel, compressor housing, bearing structure, seal structure, shaft, turbine wheel, inducer, exducer on it, and the compressor wheel, seal plate, some of the features of the compressor housing, obviously, some of the features of the bearing housing. Seal. The exhaust housing, or the exhaust piston ring seal, fits into this seal bore here. And again, may not translate very well onto the camera, but it has an end gap, and these will vary depending on the fuel that we're running. We set these up differently for a street car versus a diesel engine versus a alcohol drag race only car, but average is about 12 thousandths in gap in the piston ring, and you have clearance around that piston ring in the turbine shaft groove and at the floor of the turbine shaft. So it is never a positive seal. So its job was never 100% to keep oil out of the respective housing, but more to keep exhaust or compression from the or suction from the backside of the compressor wheel from pulling oil out of the turbine house, or bearing housing, excuse me, and or keeping exhaust from your turbine side getting into the oil on your bearing side. All right. So, and we'll flip you around for this. I appreciate y'all guys watching and making comments, and I try to shoot these videos basically as a one-shot wonder. I am working on some editing, and I try to be as thorough as possible, but it's human nature. We're going to miss some things or breeze over some things. So if you want some clarification on anything, drop me a comment below, and I will certainly help you out. But also look for more videos coming with specifics on each one of those parts. And we're going to go into pretty good detail on them. I think more than what has been covered that I have been privy to on YouTube so far. But we're also going to cover some journal bearing turbos. We're going to cover some small frame, basically just anything out there we can. So this content's going to keep growing, and I appreciate y'all guys if you were be so kind to like it and do all the other things YouTube wants you to do. This isn't about money, it's about awareness, and I want people what goes on with these guys, because it will certainly help you, and it gives me a reference to send customers to as well. But we certainly appreciate it. All the parts are super exciting. I've been doing this as of this video 27 years as a business, and every day I still get a little bit excited. I still learn something new. So we're going to share all of that knowledge with you just a little bit at a time. Guys, thank you very much. Y'all have a great day.